Sir, it's ready, sir. Yes, sir. Please connect. Sorry. Ma'am, we are sharing new link also, ma'am. Ma'am, sharing the latest link now. Ma'am, it is live. It is live.
What you have shared the text to what is Madam, ಈ ತರ ಎಲ್ಲ ಮಾಡಬಾರ್ದು. I will have to go with a complaint about it. Please. See, speaker himself is calling me and complaining. If you are not serious, leave it, madam. We are
entire 2 days we had to come over here from that campus in here. So from that time, I think the trend started from 2015 maybe. Now it is like really impacting all the industries. Just to talk about machine learning. So what is machine learning, right? Basically, when I did my studies in machine learning in my master's during my master's in Canada, prior to that I was probably learning Python and going ahead about understanding how the library works, how to use the library in terms of TensorFlow, all the other libraries, right? But it's not just about libraries. Machine learning is much more than that. So basically, machine learning, the basis of machine learning is mathematics and statistics. So why is that? Because we are trying to make machine learn on its own based on the inputs that they are giving. So this is not something that we are just giving an input, executing something, and then getting the output of it. So here there are probabilities. Here there are linear algebra that are involved, calculus, optimization, all such things. So that is why mathematics and statistics really become a base of this. Today you might have heard about LLMs, that people just take the APIs and then connect to it and then build some kind of software on top of it. It's not just that. So somebody who is just using that and work on that is not exactly you can call that as a complete machine learning. So So machine learning, they need to understand how the algorithm needs to be tweaked at each stage. So we'll look at some of the examples later, how it works. But just want to emphasize on the amount of importance that is needed on the mathematics and statistics in machine learning. So coding and engineering comes up to 30 to 40% over here. The main thing here would be for implementing models and algorithms, tweaking the algorithms. And one of the major importance for coding and engineering would be on the data side. So preparing the data, collecting the data, the way we collect the data for training the model itself is a very important step in the machine learning process. Without data, we will not have a complete algorithm or a trained model which will help us, predict something very well. So this is why data comes in it takes a major role in this. We'll discuss about data as well. And then coming to the domain knowledge, of course, this is the base of it. People have to know the domain knowledge. So this is how a machine learning should be structured, in my opinion, as per what I have seen with my experience. So yeah, that is the thing. You can see on the right side diagram that AI is the bigger part and machine learning is part of AI, because there are other things as well, robotics and stuff, which will come inside the AI. But here we are mainly focusing on machine learning, deep learning and neural networks. Let's talk about deep learning. So basically deep learning is something where how we are training the model of in the computer basically to understand some kind of a input and probably predict the output of it. So what the building blocks of deep learning is neural networks. Just like our human neurons, how it understands when we see it's a chair. We know that by intrinsic capability, we know that we see something, it's a chair, we call it a chair, we know that, right? So machines can't directly understand, so we need to train them to understand in particular way. We'll see how it is done. I'll take one example later. But the second, not the second, but the most important part of deep learning is also data. It's basically data driven. So the amount of data set, how we take, will matter a lot when we are training a machine learning model. Okay. So right side you can see the diagram where we have input layers, output layers, and in between the hidden layers. So we'll expose the hidden layers later. Just to talk about what these hidden layers are doing is, basically these hidden layers are the ones which are taking the inputs and filtering them and adding multiple layers to it to see, to predict, to train the model. So that is what the hidden layers are doing. So we'll come to that. Deep learning, right now the application of deep learning is in images, speech, text. These are the major applications of the deep learning so far. So just taking one example of convolutional neural network, this is one of my favorite subject to be very honest. So basically I'm taking one of the example of neural network, which is CNN, which probably is quite easy for any beginners to understand what it is. So basically, what is convolution? Convolution is something that is quite complex to understand. This convolutional neural network has certain things, the way it is done. Let me go to the link that I have provided in the reference. So basically, I'm following Google's machine learning, document. So Google has really documented well on the machine learning. It's much easier for us to understand, for anyone to go through it. I'll share this link towards the end. So you can see how well structured the Google machine learning CNN document is. So let's talk about what happens in CNN. So the way the machine learning, especially the CNN, understands, trains the model is like this. It uses feature map, which is a 3D matrix. It uses ReLU. So basically, ReLU is some kind of a non-linear thing that is added onto the images that we take, and then pooling. I'll go through this in detail, but just to explain what is feature map. So feature map is something that we take as, we need to consider the pixel that is there. So I'll take the example of the cat over here. So let's say this cat image itself has about 5 by 5 matrix. Okay, that means 5 by 5 pixel. So it can, in reality, it will have bigger pixels. It can have 10, 20, 24, 2024 or 2048 pixels that usually that's the thing. But just for understanding purpose, we can take this. So basically, it's like, imagine this image is of the cat, okay, and the entire blue one is for the cat, and the red one is what we are cropping the image of the cat. Okay, we are cropping the image of the cat like that. So if you see, we are breaking down 5 by 5 matrix into 3 by 3 matrix. That's the total number of possible options that we have. What we do with that? So that becomes more important. So we create multiple layers over here, which are these 3 by 3 matrix. We are cropping the image of the cat. So what happens here is, we are trying to understand each pixel of information of the cat to see what are the features that it provides. For example, the cat's ear, cat's eyes, cat's teeth. These are the features of the cat which will be taken in the layers of the modules that we have. So in reality, these modules can go more than 2. Right now, for example, we are giving 2. It can go more than 2. The bigger the layer of this module will determine how accurate or what is the potential of the algorithm itself. Okay, so basically what it does is, you can see the multiple layers over here that is coming in. These are all the cropped images of the cat, just to put it in a simple sentence. These are all the cropped images of the cat, and on top of that we'll apply ReLU, which is a non-linear aspect of the algorithm. So this makes it difficult, but basically what I mean by difficult is, we need to make machine understand even the difficult part of the images. So let's say if I take one cat and probably photoshoot the cat some 1,000 photos and train the algorithm based on that. The machine can understand only one cat. Machine will not be able to understand if I give any other cat, if I give a grey color cat, machine will reject that it's not a cat. So for machine to understand, we need to input n number of images, different types of cat, different colors, different size. For example, let's say we train all the cats from what we have in India, and you give some Persian cat. It will say it's not a cat. So basically, we need to consider all the images. So this is when the data becomes very much important. How we source the data, how we collect the data, what is the varieties in the data that we have. So this is very important process before we start training the neural network. We need to make sure we collect enough amount of data. So I would say, like when I did my CNN, I did a CNN on number recognition. So basically, let's say the old houses would have handwritten numbers in front of the house, right? Hello? Yeah. So yeah, basically the old houses would have handwritten ones, which would not be that much recognizable, right, by machine. So I worked on that project to make sure the each numbers are identified properly. So for that, if I say, let's say I take images of those numbers from one area, it's not sufficient for me. I should take more than one area. I should take Bangalore. Probably I should go more than Bangalore. So this is as much as data I give to the system, it will be able to give that much amount of good output. So that's the understanding of the how to collect data. As much variety, it is good. We train the neural network with 1 TB of data. But if I would have 4 TB of data, I would have even more better algorithm. So that's the understanding. But after getting the data, once we start developing the neural network algorithm, it depends on how many layers that you're going to have, how many variation in the module that you're going to have. For example, let's say the module 1 that we are seeing here, it identifies certain like I said, eyes, hair, maybe teeth, like this. The second model, what it does is, we have to add, combine few features of the cat. So, eyes and ears, okay, eyes and leg, eyes and the entire face of it. So this way, it takes few features from the previous module and combine it and say, okay, this is what the features of the cat is. And in the next layer, we try to understand the whole body of the cat. And here we are having, we will have more than one cat, the brown or greyish color cat. So all these kind of things. So that is the way neural network needs to be modeled. So that is the reason there is filters. So one thing to take away is basically you need to have the feature maps. Feature maps is a 3D matrix, and then add a ReLU. ReLU is basically the non-linear aspect of it, which makes it much more difficult. So just to give an example, what is ReLU? You can add a filter. So you might have seen the old reels, right? When you take photo, the reel kind of camera that used to be there. So that has negative and then converts to positive, all those kinds of things, right? So you can add a negative to it to see to make the machine understand even the negative texture of the image. So making it difficult for machine to understand will be easier when we are going to implement or when we are going to predict the things in the future. So basically, the first thing is training. It all depends on how we are going to train the model and then how we are going to use it while execution. So while execution, it becomes more important. Okay? So that is the thing about neural networks. So please go through machine learning documents, and Google has very well provided the very well documented the machine learning concepts. I have also added the main link where you can see multiple different where you can see multiple different kind of courses. They have made a really good modules out of it. You can go one by one and learn this. It is really good for I personally felt it's helpful for anyone to start from who is starting from beginning. Okay. So coming to the applications and trends. So AI applications, right? One of the major industry that is changing based on AI is medical industry. It's hugely impacting and it's benefiting medical industry in a huge way. What we were able to identify 10 or 20 years back is much faster today. Maybe it used to take 7 days, 8 days to identify something. Today we are able to identify that within a day. And having a really good algorithm and predicting. So something called as false positive, right? What is false positive? Identifying detecting something as positive, but actually it's negative. So for example, many times doctors might have, for example, you might have heard, right? So something has been diagnosed and it was wrongly diagnosed. So such problems are solved based on how well the neural networks or how well the machine is trained. So that is where the implication is. Okay. So as you can see that these days cancer detection is one of the primary thing that machine learning is working on. How to detect. So basically identifying cancer much before is the key to it, right? Key for the cure. So that is where machine learning is working on, investing heavily on that in that area and seeing the outcome. And then self-driven systems. So basically you might have heard of Tesla and all the other cars that are coming out of China and stuff, right? Like all the newly innovated cars. I think one of the workshop that I was talking about, which we did here, was something based on the self-driving cars here. So and then improved security system. So imagine having as we were talking about cat, right? Let's say we have human face detection. That's one of the important thing. I think many of your students might have worked on that face detection projects, right? So let's say identifying some kind of a threat or some kind of a criminal through camera, which is improving day by day. So these technologies are improving our like securities day in and day out. Advanced robotics, predicting sales and generating marketing plans. This is one of the very interesting points, since I am also head of technology in InnoCraft. InnoCraft is a digital marketing company. So we are using this AI, machine learning day in day out in InnoCraft. These days we are seeing a lot of improvement. One of the things I just want to talk how it is impacting businesses. So for example, in digital marketing we do run Google ads, Meta ads, where people want to promote their products or they want to promote their services. So basically the conversion when you run the ads, the amount of money that you put and the conversion out of it, if you calculate it's up. Right now it's about 4 to 5%. That's where it is. But machine learning is able to solve this. And personally, we are taking some of the new tools that are in the market. Many people are working on this. There are many new tools that are coming up. What they're working on is to increase that 5% to 6% or 7%. Just 2%. Just imagine. We are somebody telling that I'm going to build a big software to increase just 2% of sales. It looks like, okay, it doesn't really matter. If I increase 2% also, it doesn't really matter. But this 2% is impacting business a lot. So that is where the impact is. Today we are just looking at 2% of increment, but in future we will be looking at much more. And we are able to do like purchasing patterns in e-commerce. How basically when you see social media, see how the user is interacting, and if that particular user is interacting with some kind of certain things in social media, maybe we are predicting, okay, this can be a potential customer for this kind of a business. Probably, say for example, you are getting a lot of street food videos or something like that. You can sell some kind of a Maggie, or just for an example, if somebody is selling Maggie, then that person is a very good potential customer for you. So this is how machine learning is able to solve the issues in business. What are the trends in 2025? The major trend that we saw was generative AI. What is generative AI? Generative AI is basically, you have seen ChatGPT. I think everybody might be using ChatGPT now, right? We are able to generate text. We are able to generate content much faster than what we could do before. And then we are able to generate images. You can give some prompt and you are able to generate images to it. So at InnoCraft we are using these things day in day out. When we are creating posts or when we are creating some kind of a reports, we are generating images from AI. Probably two years back, if we had generated images from AI, we wouldn't have used it in the live examples or in the projects. The reason was 2 years back, it was not perfect. It was not even close to where we wanted to be today. So that was the issue. Today you might have seen on the social media that an AI, Sora AI, is able to now generate an entire movie of its own. Maybe some kind of a person interacting. There used to be a glitch when with the human face, with the human interaction, there used to be a glitch before. Nowadays you can see that glitch getting reduced because of all this advancement in the AI, where you will not know the difference between if it's really a photo shot or if it's a AI made. Which is also, I think one of the campaign that went on was about whether you are safe or not. If AI is able to generate perfect picture of your own self, that's also one of the threat that is there. We'll probably talk about it later. But yeah, one of the other thing is edge computing. So edge computing is something that is not, for example, let's say cloud computing, that is today's world, what we see. Everything goes back to one server. All the requests that goes to one server, right? Which, let's say, if you want to predict something, if you want to predict a threat, it's not really that. It doesn't help us if it takes up to 2 seconds. 2 seconds today is too big for computational power. We need things in less than 200 milliseconds. That is where the world is going. So what is edge computing? Basically, edge computing is decentralizing the logic behind the server that used to be there. How we do it? For example, let's say cameras, right? Face detection. Face detection, cameras has to capture that. It has to send that footages to the server, which is somewhere in the cloud, and then the cloud has to process it and then come back. So this takes a lot of time. We want to cut it down and bring it right into the camera sector. So basically, all the buzz about IoT that we talked about it, right? So the author is going to have a really good impact with the edge computing. Cybersecurity is one such field that is really getting impacted in terms of AI. Let's say somebody is sitting and understanding where the request is coming in the network. If a human is sitting over there and trying to understand where the request is coming and going back in the network, it might take a lot of time. But with AI technology today, we are able to scale up cyber security very well. Quantum computing integration is one such thing that we will be talking about in detail in the second half. But yeah, quantum computing is really catching up a lot these days. Challenges in AI. So there is one thing called as bias in AI. So what is a bias? Just regularly talking, right? What exactly is bias? Bias is something that we are leaning towards something that probably we like or we have been taught or something like that, right? So just like that, we are training AI here. That means we are teaching AI something. Like I said, based on the cat, taking the cat example, let's say I only train the neural network based on Indian cat, it will reject Persian cat. So basically, data makes a lot of difference. So a cat example may not be that important here, but think about what happens. What would happen if AI gets into the law enforcement? AI gets into a hiring process. Let's say AI only filters all the students who have 90%, 90% marks and all that, and only those people will get placed. What about the rest of them? So if AI becomes like that, if somebody trains the AI who will only pick the top students, you are leaving out all the other students, which is not really good. So these are the bias. These are called as bias in the AI. It mainly depends on what kind of data that we are going to feed into the AI. How we are training the model, how we are collecting the model. How we are collecting the data. That's how it becomes much more. As much as data, as much as variety in data will help us in having a better AI application. Data and quality, which we spoke about. Scalability. So data always, as I said, like if I train the model on 1 TB, if I add 4 TB, it would be better. Data is always going to increase. You might have heard of big data, all the kind of thing that is there in today's thing, right? Data is going to increase exponentially. And we probably don't have that much capacity to hold it. Ethical issues. So basically, here is where the issue comes in, like job loss and all those kind of things that people talk about, people fear about, right? So this is something as engineers will not be able to take to an extent, we'll not be able to take a moral thing on that. But I would suggest, I would say, as engineers, we should see how to control, how to keep it in our control. What people today are talking is, AI is training other AI. That is when it becomes more complex. That is when it goes out of human control. So once it goes out of control, if one robot is able to train another robot, then it's not really that good, right? We should have some control system where humans are able to control it to an extent where we can say this is unethical. We should not be doing this. After all, robots and AIs are basically systems which really do not possess any emotions. That's what. Now coming to the computational challenges. So basically we'll talk about this in detail when we go to the quantum computing. Just training, for example, let's say when I did, I'll take my example. When I did train my neural network, to run that neural network, to train that entirely, it was taking up to 45 minutes in my system. So that is the amount of time it used to take. And that is just one TB. Imagine having 100 TB, massive amount of data. This is going to take a lot of time, and if there is any error, you have to run it again. You have to train it again. So this is very frustrating. So this is where we need to have much more higher computational power systems. That is where the invention of quantum computing, which is much faster, comes into play. In today's computing, even the supercomputers that we talk about probably will not be able to beat, even if you increase RAM or anything as such, will not be able to beat what quantum computing can do. So, before we move to the next quantum computing, have any queries or anything to discuss? We can discuss moving to quantum computing.
Basic programming language, anything is needed for AI?
Yeah.
We don't know anything, any programming.
Yeah, Python is the major thing that you need to go
Any
for.
alternative to that?
So far, Python is the best. Don't want to confuse with other languages. Best to learn Python and go ahead with it. The main reason is it provides a lot of programming, a lot of libraries which are already available in the market. Having said that, as I mentioned in the first slide, it's not just about using library. They should also know about what is the basis of it. And the base is always statistics. They have to go back to statistics and understand how the library is built. What exactly it is doing. So just to give you an example, I'm also taking program-based learning in DSATM. So there I see students, they're taking up projects. Okay, we will do AI. All they do is just plug in something and they will leave it there. And one guy told me, I have a perfect machine learning this one, and I will show you. So he said gave something about dog and stuff, generated a lot of images. I just told him to generate one image. I told him to generate a dog with a backpack. It gave dog and backpack separately. So that's not the thing. So basically they say we have done it and have completed. They would have not gone to the base of it and understand what exactly it is. What is the base of it is something that they need to understand. So Python is one thing that will help. The main reason is Python has libraries like NumPy, all such things which is easier for us to work on metrics. Metrics plays a lot of importance in machine learning. They need to know basics of metrics. So that is one thing that they need to know clear.
Thank you.
Yeah.
Sir, one more.
Yeah.
So the AML only needs that mathematics, or is it required physics, chemistry background also required? Like what kind of physics, chemistry concepts will be? Like maths we are using statistics and probability calculation. chemistry, any particular classical mechanics, or is it required?
Physics can come into a little bit of play. I think where you look at the problems and stuff. And one of the major things physics come in is in the quantum machine learning. We'll be talking about that. But as such, machine learning today not much impact with physics and chemistry.
Completely mathematics.
Mathematics, statistics is 50% of it. And that is the base. They need to understand how the algorithm trains. So basically what happens is when you train, we measure whether the accuracy is correct, whether it is overfitting or underfitting. What is overfitting? We are trying to have the same amount of data, same kind of data, and we'll say, okay, we are accurate, we are 100% accurate. That is not the correct. Or underfitting. They will say they'll take each different varieties, each image is a different variety. AI will not be able to understand that. So these are all the concepts that are coming from statistics and mathematics. Probability, calculus, these things that are coming from, the base of it is statistics and mathematics. When I studied machine learning was a course in my 4th or 3rd semester or so in my master's. They didn't teach me anything about coding. Coding was left to us. They only taught mathematics and statistics. So that's where it was. Yeah.
So do you think this next-net model gives a better performance than your CNN for
Uh,
image processing applications?
Yeah, I mean, to be honest, I've not experimented with that network. There are many different models that
Because
are.
there was the constraint in
Yes,
terms of context.
yes. Yeah. I took the classic CNN example just for the basic understanding for everyone to understand clearly. There are many more models as such which we can use in today's world for generating AI and all that, which is much more better than what CNN was. CNN probably I can say is now kind of old, it's taking that step. Yeah, but now there are a lot of things that are coming up.
Which are the latest applications where AI is being used? See, apart from generating images, apart from that, which are the applications where, like medical field
Yeah, medical field is one.
whether it is implemented or it's still around the initial stage?
No, sir, it's already implemented now. Medical field have already started using it. See, the invent of AI or the advancement in AI started in 2015. Today we are in a good place where AI is implemented in many places. And one of the other things, as I mentioned, is also business, where we are looking at sales and marketing. So that is where AI is playing much more bigger role as well.
Where it comes in business?
So basically identifying the customer patterns. So let's say you're online now and you're trying to browse something that is interesting. Maybe some songs that you like, that your choice. Probably what happens is, let's say you want to see some old songs or something like that, and then you go to Spotify. That song may pop up to your list. The reason is Spotify is able to track your patterns and understand, okay, this is the thing that it suits you. So, and then if you like the Spotify thing, tomorrow you might go and subscribe, and they have a customer. So that's how it is, building the customer base, understanding the pattern, and even they are going to an extent to understand the mood of the customer. At what time, maybe for example, in the morning, Monday morning, everybody is frustrated. So they don't want to show some kind of ad. They want to show some kind of ad that is calming to the people. That's such kind of patterns that they're trying to find, and shows that kind of service or product to you, which you will tend to buy than if you're in a different mood.
We have a lot of options still. We are not implemented in many
Yeah.
space. So
Correct.
even medical images and all, MRI scan or whatever,
Yeah.
even scanning images and all.
Yes.
See, we may not be clear. So
Mhm.
that we can clear. Already it is there, traffic,
Yeah.
they have put AI cameras out there.
Yeah.
Like that. See, just to coming to our
Day-to-day use.
it's going into business
Correct.
instead of day-to-day needs and all.
Yeah. That's also based on the acceptance that is there. So it takes going to come to one level, and maybe there are a lot of yes and no towards some kind of invention. So it is taking time. But also on the back end, as I said, the computational challenges are a major thing today. Why they are not able to release it to everyone? Because today, probably I think yesterday there was semi-finals, right? There were about 63 crore people on the Geo Hotstar. Today we have that much capability in the back end. They will have a huge server in the back. I think 5 years back, if they had it, if at least 10 crore, or not 5, 10 years back, 10 crore people, if they had got onto the application and watching the live streaming, it would have broken down. We have heard many times back in the time when a lot of issues that used to be. Now you don't see that much issues in the live streaming. So that is how the AI is also transforming slowly, and it is coming to day-to-day activity in a very less speed manner. Okay, so we'll start looking into the quantum computing. To be honest, I have started learning quantum computing very recently, and I've been trying to understand the advancement in it. I'm also as much, probably you can say I'm in the level 1 or level 2, if you take from the level 5 up to level 5. So basically, what is quantum computing? This is derived from quantum mechanics. Yeah, wave-one particle duality. So basically, if you compare it to current scenario, what we have in the current system, it looks like magic to people. It looks like magic. What exactly the duality or multi-state simultaneously is? You are present in both the states. If you ask me a question which has answer yes or no, the answer is both yes and no. That is the kind of concept that quantum computing has today. It is still in a very, as I said, it's still a magic for people to understand what exactly it is. It is very new, as we see it. Quantum entanglement is one thing that makes things much faster. The purpose of quantum computing here is to have computation much faster than what we have today. That is the purpose of it. The old classic computing only understands 0 and 1, either true or false. That's all it understands. But we have never tried to get the probability into it. That is what quantum computing is all. Just to tell what is quantum entanglement, the image represents there are two particles kind of connected. That is the concept behind that. So just to on the fun side, I'm from the 90s, and there were some movies where you have seen there are twin brothers, and one guy is weak, one guy is strong, and the strong guy is caught somewhere. The weak guy is with people. He has to go and fight, but he don't know how to fight. Basically, what the strong guy does is he do something like this. The other guy is copying it. So that is the example, very rude way of explaining what is quantum entanglement. These two are connected to each other, and they are doing the same motion what the other person is doing. So this is the basic understanding, I can say what it is, to not make it very complex. So it's like existing in two different places and performing the same thing. That's where the parallel processing comes into picture.
So real life also it's same. One of them get fever, the
Other get fever. So just an analogy of it. A simple way to explain is light switch, which is there on or off. That's the classic computers, and you have a dimmer switch, which you can slowly you can reduce. So when you reduce, it's not really off, it's on, but it's just reducing the amount of current that is getting passed to it. So that's basic understanding of it. So this is the difference between classic computers and quantum computers. Classic computers understand only 0 or 1. A bit is the smallest information that a classic computer exists. So basically, it's either 0 or 1. Quantum computers has qubit. Qubit has 0, 1 or both. So this is the basic unit of the quantum computer. Processing, sequential and parallel. As I said, like since it can exist in multiple positions, it's called a superposition. It can perform twice as better as what the regular classic computers used to perform. Storage and operations. You can see storage on the classic computers is fixed and deterministic, whereas quantum computing is probabilistic. What is the probability? So, I mean, what is the probability that I will reach my home in 10 minutes? Depends on traffic, right? That's where it is. That's the understanding of quantum computing. It looks at multiple different probabilities. If there are some Marvel fanciers, you might have seen the probability thing between Doctor Strange and Iron Man, where he says, "What is the probability of winning this war?" He says there is only 1 at 10. So that is where it is. So probability probability is the basic of quantum computing. If you want to play a toss game with quantum computing, the computer will always win. You will always lose because it also has heads and tails. It has heads and tails at the same time. So this is the kind of thing which we have to, this is where we have to draw a line and say, don't compare exactly with classic computers to your quantum computers. You need to understand it in a different way. I read somewhere quantum computers are not actually evolution from the regular classic computers. The reason is it works in a different way. That's the major reason. You have to look at it as a spectrum where zeros and ones, in between there are a lot of imaginary numbers. So that is where we have to look at. We spoke about speed. Quantum computers are much faster. Security. Quantum cryptography promises stronger security. So this one concept probably I'll not be able to touch on in this session. But the thing is, if anybody is interested in cyber security, please go and look at this quantum cryptography. It is really good. It will be the future of cyber security what we are looking at today. So this is something that if you are interested, please go and search on this. It is really good. Okay, so now coming to the qubit. So yeah, I mean I have a bit of formulas and stuff over here which will explain how it works. So basically, the way it is represented, qubit, zeros or 1, is like this. It is not just one bit that is represented. You can see it's a matrix. The 0 is represented with 1 and 0, and 1 is represented with 0 and 1. It takes a bit of time to understand what exactly it is, but the basic, to put it simply, you can see the dash and the arrow mark which in between 0. What it says is, what is the probability of this bit being in 1? What is the probability of this bit being in 0? It can be 70-30. It can say, okay, this bit is 70% in 1 and this bit is 70% in 0. So this is the understanding of it. There is no straightforward understanding, okay, this is fine, this is 0 bit, that's it. It's always a probability, 70-30, 50-50. That's how we are going to measure it. I'll just deviate from the slides to this particular geek for geeks. So they have really represented this very well. When I was doing research, when I was learning quantum computer, they have really represented the how the bits are represented in a very well manner. I hope everybody is able to see it. Yeah, the state was 0 is represented 1 and 0, 1 is represented 0, 1, and you can see the notion that is called as Dirac notion, where 0 is represented in 0 bit is represented in matrix and 1 also represented in matrix. So the arbitrary state, this is one interesting thing which will help us understand the next part of it. How to go about understanding the quantum computing and how it works. So arbitrary state, you can see this bit, it's either represented like this or this. Let's take the second one. The reason is you can really see how it is. It's kind of like the one to determine one bit. It's the probability of alpha into 0 plus beta into 1. So that is alpha is the percentage of the probability. Alpha and beta are the percentage of probability of that bit being in 0 or 1. So for example, 70-30 is the 70-30 is the probability. This bit is 70% 0 and 30% 1. So that's how the representation is. And where this leads to is Hadamard basis. So you might be familiar with the regular classic computers gates, AND gate, NOR gate, NAND gate, XOR gate, all such things. Hadamard gate is the major one which helps us create this what do you say, the superposition. What it basically does is it basically 1 second, I'll just open one of the stock exchange. This is what the Hadamard gate represents. H is equals to 1 over square root of 2 and the matrix. The matrix is 2 by 2. It has 1 1 1 0. Sorry, 1 minus 1. So right now, as you see, this is how the gate will be implied. On the 2 bit, what we do is for the first bit, we apply the Hadamard gate to create the superposition. All it does is, if you see here, the equation, anyway, the link is in the thing, I'll share it. It creates Hadamard gate multiplied by the bit. The bit is basically 0 or 1 or 1 and 0, right? You can see this multiplication over here that is coming in. And that creates a superposition where you are getting two different bits. It splits one bit into two different bits. How? Basically multiplying 1 by 2 matrix into 2 by 2 matrix. It creates two different bits. And now the probability gets implemented over this. So these are the basic gates that are in the quantum gates. Hadamard gate, C0, poly gates. Just the basics of it is Hadamard gates create superposition. I would really suggest to go through this. It really explains the concept very well. And the C0 is basically like the XOR gate. It creates the entanglement between the two. So let's say, what is the input for XOR gate? If you look at it, what is the truth table for the XOR gate?
0 0 0.
Yes.
1 0 0 1 and 1 0 1 0.
Yes. So that's where it is, right? And the input is 2, output is 1. Whereas on the C0 gate, you have 2 inputs and 2 outputs. The reason here is one of the output will retain its original form, while the other one inverses. So you are creating two different states where it is much more, basically you're looking at whether which one is the, based on the probability, we have to take a call on what exactly is the value. So the input on the XOR gate is 2 and the output is 1. Whereas on this, input is 2 and output is also 2, where the one of the output retains the original value, the other one switches the value.
That's on the condition. When A is true, it will operate on B.
Yes.
If it is not, it will not operate on B.
Yeah. So that is the thing. And now coming to poly gates. So now exactly, if you imagine 2-bit, right? 2-bit, which is classic computers. It's a 2D matrix or 2D space, 0 or 1, X or Y. That's all there is. So if X goes to this, it becomes 1. If X comes to center, it becomes 0. And Y goes to the log vertically, it becomes 1 or it goes to 0. That's where it is. But you have to look at quantum gates or quantum computing as a sphere. It is in 3D, it is in 3D space, where we have Z, that is ranging from 1 to 0, and you have, I'm not sure if you are able to see this properly. You can see this, okay. And then you have Y and X, which are in the imaginary values. This is where it is. So you can see this is minus I, and this is I, and this is plus and minus. So you have to look at it as a 3D which is in the space. So polygates basically XYZ helps us in like a NOT gate, switches from one axis to another axis, just to change the information if there is any change in the information. So basically that's what we do here, right? Whenever we have, let's take classic examples, if condition, else condition. If this is true, then do this. If this is false, do this. Or change the value of that if value. Similar to this, we are using these gates to change the value of certain variables. I have given some of the reference here which can be really helpful. You can have a look at that. Now coming to Qiskit. So what is Qiskit? So Qiskit is basically, you might have heard of SDK, right? SDKs are something which helps you in building the application, something which helps you in building some kind of logic that are there, right? Qiskit helps us build the applications in the quantum computing. I'm taking the classic example of IBM. IBM has been really a pioneer in creating this quantum computing. Basically, you need to create one account in IBM, quantum.ibm.com. You can create an account, you'll get an API token, which you can use to do programming on this. So let's simply, I have some simple program over here which I worked upon. So basically to install it, I'm using Python. Python is much easy to use for this purpose. You can install Qiskit with Python, similar to this. And basically you need to import the library of Python runtime, Qiskit IBM runtime, which helps us in running the program in the IBM server. So right now the logic when you run, it will be running it on that server, not on your local server or any other server. So that's how it connects. We'll have to create this Qiskit runtime server, provide the channel, and provide the token that you get in the IBM dashboard. Now, just a simple thing that how to set up the initial variables. So this is the thing. As you can see here, quantum circuit. You can import quantum circuit from Qiskit. So here you need to first create the headmart gate, which will create a superposition for us, and then you can create the C0 gate to create a quantum duality. You can see when you output this, when you draw this, you can see the headmart gate and the C0 gate that is implied, and with this we can start all the computation. I have a simple example of where I have given the observables. Poly is the XOR gates, and once you run that, just to observe how it works, you can see the expectation in the observables. I know this may be a little bit confusing, so what I have done is I have linked the YouTube course where you can go through and work on this and understand how exactly it works. It's much easier. But what I'm using is Google's Colab. Google's Colab is easy for us to work on this. Instead of setting up the entire environment in your local, it's much easier for you to go to log into Google Colab and work on the quantum computing. Okay, so basically why quantum computing for AI in QML? One of the major reasons that we discussed is speed. We do not have fast computers today which can cater to our needs where we have large, huge data sets. We don't have that. So we need some of the computers which can be much faster. Optimization and probabilities. All the things that we have today in the regular computers is all deterministic, 0 or 1, which are really not helping us. See, just to give you an example, let's say if it's a simple, if you are running a for loop, and if you are running it only for 10 times, it's fine. But if you are running a for loop which is much more higher, we don't know where it's going to stop. Then our regular classic computer is not going to be handling it. It's much difficult to handle a loop iteration which can go to a certain extent that we don't know. Basically, that's what it is. Now, what happens here is the entire that much amount of loop can be cut down and we can keep it in one iteration when you're running in quantum computing. But you have to run it multiple times. Let's say instead of running the iteration 1000 times on the classic computers, you might have to run 10 times on the quantum computer to check whether all the 10 times am I getting the same result. 90% of this, 90% of 0 bit. If I am getting that all the time, then we can say, okay, this is the correct number. So that's why people say quantum computer or the qubit is always on both the level 0 or 1 until it is measured. Only when you measure it, you get to the result. But on our classic computers, you know the result because it's deterministic, either 0 or 1. So that's the major difference. QNNs are going to be one of the major things which are going to come up in the future, which is already in research level, but it's not yet implemented to that extent where we can see in today's world. And yeah, future impacts, healthcare, finance, and security breakthrough with quantum computing. One of the major things that I can see is that I think most of the movies have gone to next level where they are talking about quantum computing, they are implementing and all that. That is not the reality in today's world, but we'll probably looking at that 2028 or 2030. That's where we'll be able to see the actual implementation of quantum computing. So basically, how can faculties integrate quantum AI in research? Build the foundational knowledge. It requires some amount of daily time to provide what exactly it is and how it works, and probably play around with the Colab and see the result. Just hello world, A plus B, such kind of things you can start off with, and you can start getting the foundational knowledge. Identify research problem. This is one such thing that you can work with your students to see how you can identify research problems and if they can take up certain projects on that. Leveraging quantum computing resources. So we saw the IBM quantum experience, cloud-based one. Google also provides its own, and there are multiple. Microsoft, all those provides open source, some to an extent free version, which helps researchers and faculties to understand more. Open source frameworks like Scikit, TensorFlow. I have personally used TensorFlow, which is very good. So we can make use of this open source and cloud-based system to understand more. Establish research collaborations. So yeah, I think there is much scope for this quantum computing in near future. So basically, you can start looking at it and encourage your students to start working on these things to get a better edge towards the future. I think we are at the end of it. Any questions?
Sir, I have one question.
Yeah.
hardware we will use, sir?
Yeah.
Speaker and all.
Yeah.
Quantum computers, what kind of hardware we will use?
So basically, to my knowledge, what I've seen is it uses uh, the setup is completely different from what the classic computer is. But it goes to a subatomic level to get such particles. That's what so far I've understood to an extent. But to answer you completely, I'm not.
That's okay, sir.
Yeah.
So for what you discussed about is software, logic and everything.
That I will answer for that.
Sir?
You see, physics people has to answer.
No, no.
See, we have different choice for quantum. Either we can go with electrons. We can, where we are in semiconductor, we are going with electrons or holes. Both are there. Here we are going with either electrons. Electrons means we can use one spin up and spin down. That is electron. We can go with superconducting electrons. It is becoming more complicated. Cooper pair. You have to generate Cooper pair. It's not easy. Two electrons moving together. That's not easy. Third one, we have photons are there. Light is there. Light we can make in different directions. Polarization is there. Two polarization is enough for we people to have this all these things, entanglement, whatever it is. Fourth one, we have magnetic materials that we can use. We can make either we up or down, turn it. Magnet, we can change it, dipole. Whichever. Any new type of, we can use any of the things. We can, it is our choice. But it is, the things are becoming more complicated. If you go with the more complicated one, it will be more complicated. You see, light itself is, as Sai was telling in the beginning, that it's a magic. That's the word he used just before starting. It's really a magic. Means you see, light is a magic. Do you feel that in the earth, this is the most magic thing in the world? Nothing else. That's what I feel. See, he is telling duality alone. What do you mean? It is in the word, it is duality. It may be particle, it may be wave. But you think about how a wave can become a particle. See, we don't know what is happening. You have switched on, light is coming, what is that? Is it a wave or a particle? You will tell. See, if you want something, I suggested the boarding session. Instead of going for electrons, go for photons. Because it itself is a magic. What Bhavani told now, it's a magic. So go with the magic. That's what my choice. Lot of things are electrical. Maybe if we also sit together, we can also come up with very deep things in quantum computing. So, like electrons and holes, we have lot of choices in quantum computing. We don't have the choice there.
Atoms, just at very low temperature, these atomic states can be manipulated with different energy values. Those also you can include for parallel computing. Especially these radical dystopian.
Spintronics may come. Spintronics may come. You can also come. Okay, then. Just first time I am explaining this much.
Thank you, sir. Thank you.
Well, you sit and think, it's a wonderful world where we are living. Particle means some meaning is there. Light means some meaning is there. You explain it. What is light? You can explain. I can't explain. I am a physicist. But I can explain.
You want to know what is happening behind.
Okay.
You want experimentalism.
So why we ask if we are in electronics, we will be embedded system. If you want to develop software, you should have hardware.
So that's why
Yes,
That's why
AI,
for this software, what is required in hardware,
AI is
material,
in
what is
Moore's law, they
required.
are telling, no, Moore's law, you know. AI is in Moore's law. That is the latest application they are taking.
Thank you, sir.
I
Thank you,
just
sir.
support
Thank
you.
you, sir.
No, to be honest, I think you rightly mentioned that it is a magic. It's coming from the HOD himself. It is a magic. So that's where I try to go in depth. I think with my limited knowledge on what exactly subatomic level, but that's what even I could feel. Basically, we don't know where exactly it is. It takes a lot of time. One of the things that I understood as a software developer or who has been in the software industry for 10 years is you have to look at quantum computing in a different eyes than what you have been looking at this current classic computing. You have to have a different eyes to go about. So that's the reason.
That we could understand the matrix clearly, sir. All these matrix, when you showed the programming, no, we could understand it clearly. Thank you, sir.
Thank you. Thank you.
I have one question, sir. We have a classical control gate, is that external
Yeah.
control. Is it similar to that where what we are using a C control, we are getting the control. Is it a similar
It is somewhere that's what
working principle is same?
same.
But
Yeah.
here it's classical, again we are going into classical.
Just to like bridge the gap between the classic and to understand. But I think we have to do a bit more analysis and research to represent it in a better way.
Both are okay. If 0 bit is there, 1 bit is there.
Yeah.
But one of them is controlling the other bit.
Yeah, exactly.
But it is a classical way of controlling.
Classical way of controlling it. Yeah. It's just a representational way of showing it. But I think that has to change.
Yeah,
To slowly change the mind of people, okay, this is exactly it is. Just like how people invented gravity or anything else. So, yeah. Thank you, sir.
So I would like to extend our heartfelt gratitude to Mr. Bhavani Shankar PR for sharing such valuable insights with us today. Thank you very much. I would like to request HOD sir, Dr. C.M. Joseph, to please give the momentum to our guests.
Coming. Coordinators. Coordinators. Coming. Come. Coordinators. Boys. I don't know why it says what you should.
One group photo.
All of you try to make the things engaging. That will be
Students come, we'll have a photo, group photo. All of you have LinkedIn, no? LinkedIn account is there? Yeah, they are updated in the LinkedIn. Can check it. Every day we update in LinkedIn.
Sir is giving internship also from his company. Let's talk to you and take the knowledge.
I ask you one question.
Oh, that's good. It's always good to have an engaged session.
Only from technology. You're not getting
Yes, sir.